video I'm making some burnishing rollers that fit my knurling tool. This is my knurling tool, and the rollers are just a plain roller with a good finish on, and these will burnish a diameter. We also look at how much the size is reduced when you burnish a diameter. So let's go into the workshop and see how we do it. This is my knurling tool, and it works by clamping this down. The two knurling wheels clamp together. And what I want to do today is make a burnishing wheel, which is exactly the same as a knurling wheel, except there are no teeth on the wheel. It's smooth, and the idea is that as you clamp it onto the workpiece, it will give you a better finish than the turned finish. So to start off with, I want to make two wheels the same size. I'm not sure what the material is, so if it's mild steel, I'll have problems hardening it. Okay, I've tried to heat treat these, but they're still soft, so they're mild steel. And the next job is to give them a good polish on the outside so they've got a nice smooth finish. So I've just got some emery cloth. I've put them on a bolt to hold in the chuck. Take those off the bolt. So I'll fit the wheels that we've just made into the holder. Okay, so this is the bar I've just turned, which has a fair finish on it. Not brilliant, but say we wanted to fit a bearing on here, and we just want to improve the finish. Now I'm going to see whether these plain burnishing wheels will actually improve the finish of that bar or not. I'll put it on a slow speed. Tightening this clamps them together. Wipe the oil off. You can see it's starting to get a better finish on the very end, so I'll just do it a bit more, put a bit more pressure on. whether you can see how the finish, that is really smooth compared to this. So I think this would be useful if you're trying to fit a bearing to a shaft and you come down near the sides but you've only got maybe 1 thou or 2 thou left. You know that when you turn your tool in and take the next cut, it's going to take about 4 thou off. This would be useful because you could actually size it with the burnishing tool to the right size. So I'll just do a bit more on there and then we'll see how much in diameter the bar has altered. So we'll measure that bar, see how much it's altered. I'm just putting 2 slip gauges or gauge blocks there just to support the bar, and I've cleaned the bar. So I'll roll the bar under this way first on the turned diameter. Set it to 0. Now turn the bar around and put the burnish diameter on there. About 4/10 down, 4/10 of a thou. So it's reduced the diameter, but it's also given a better finish. It's a smoother finish, not smoother finish, ideal for a bearing to be pressed on. But if I wanted to take 3/10 off this diameter on the lathe, there's no way I'd get that finish and the right size, but by just running a burnishing tool over it. So what's happened with the finish? So if this was the surface of the metal bar, when you burnish it, what you're doing is squashing all these ridges, compressing them down so that you get an even finish over the surface. It's just compressing the ridges down to improve the surface. Now if you could get some bearing races that would fit your knurling tool, they would be hardened on the outside, last longer and give you a better finish. But for a piece of mild steel, it's done the job. It would get you out of a jam. Oh well, that's it for today. Thanks for watching. I hope you enjoyed it, hope it's useful, and we'll see you next time on Enots Engineering.